We're going to look at 3.7. We're going to look at question number 2. Okay, so 3.7. We'll start off with question number 2. We're going to be looking at what's called Hooke's Law. And Hooke's Law applies to springs. So each spring has a different coefficient based upon the material that it's made out of. And that just tells you how far you could stretch it. So for Hooke's Law, for an elastic spring, it states that the distance a spring stretches varies directly as the force applied. So this is a direct variation. If the force is 20 pounds, and it stretches the spring 10 inches, then how much will a force of 40 pounds stretch the spring? So what are we looking at here? We are looking at the distance a spring stretches varies directly as the force applied. So however we want to label it, I'm just going to label it as our distance. That's going to equal K, which is the constant for that spring. And it varies directly, so it's multiplication times the force. So here's our formula. And I, again, think this is the absolute easiest way to do these with words. What do we have? We have 20 pounds of force stretches it 10 inches. So the force is 20, and the distance it stretches is 10. So distance is 10, force is 20. We'll divide by our 20, and we're going to reduce that down. So that gives us then a K of a half. Okay, is everyone okay with that? So rewriting our formula. Distance equals now 1/2 times the force. And what's our new force? We want to take the same spring, and the new force is how many pounds? We are going to apply 40 pounds of force to the spring. So what's that going to give me for the distance? Well, that gives you then a distance equaling 1/2 times that 40. So that gives you 20. And the distance it's pulled is in terms of inches. So if you apply 40 pounds of weight to the spring, it should stretch down 20 inches. Right? Do we see how that one's set up? Why do we multiply? Because what's the key word here? What's the key word? Direct. When it says directly, what does that mean? Directly means we multiply. So we set up our formula. Distance that your string stretches is equal to K times the force. In a physics class, you would get different Ks based upon different springs. Each spring has its own constant here. So let's now look at question 4. So let's look now at question 4. This one is inversely proportional to the square. So the weight of the body above the Earth's surface is question 4 is inversely proportional to the square of the distance, right? What is the effect on the weight when it's multiplied by 4? I think we talked about this one before, but we're going to go over it again. I think we did this, we went over this one a while back, and we'll go over a formula again. Okay, so the weight of the body is inversely proportional to the square of the distance. Inverse means we divide. So that's going to be inversely proportional to the square of the distance. Now, let's just see how these compare. So let's say we have a distance of 1. If our distance is 1, what does that give you? Well, the weight is just k over 1 squared, which is what? K. Now, what happens if we multiply this distance by 4? If we multiply that distance by 4, we're going to plug in a 4 for that distance, and we're going to compare them. Right? So if I plug in that distance of 4, what does my weight look like? Well, the weight is k over 4 squared, which is then k over what? 16. So how did changing the distance by a factor of 4 change the weight? It's not changing by 1/4, it's changing by what? 1/16, right? So what happens when you multiply the distance by 4? Well, the weight changes by 1/16. Why does it change by 1/16 and not 1/4? Because what did we do? Square it. So how do we determine what would happen? Well, I just used 1. So let's say we let a distance of 1. Plug it in, we got a k. We're going to take that distance and we're going to multiply it by 4. Well, if we multiply our distance by 4, we get a 4 for the distance, right? Because we used 1 to start with. When I plug that 4 into our formula, down below it's squared, and when we square 4, it becomes what? 16. So what happens when you increase the distance by a factor of 4? Well, your weight changes by 1/16. Right? Why is that 1/16 and not 1/4? Because it's squared. .1, now we'll look at question number 7. Some functions have inverses and are one-to-one. Some functions do not have inverses. This one does not have an inverse. Why does this one not have an inverse? And why is it not one-to-one? Well, it's got the square there, right? And if it's a square, or if it's an absolute value, it has no inverse, and it is not one-to-one. So all you need to write here is not 1, 2, 1. And why would it not be 1-to-1? Well, if we go to graph it, what's this -6 going to do? -6 is going to move it over. It's a square, right? So we move this forward, or to the right, 6 units. And we graph it. It looks like that, right? And what happens with this one? Why does this one not have an inverse? Because it fails what? Fails the horizontal line test. And all you need to remember is squares, unless they have a restricted domain, do not have an inverse. So all you need to write on 4.1, question number 7, is it's not 1-to-1. And if it is not 1-to-1, that means it has no inverse. Well, let's go ahead now and start looking at, if we don't have any questions out of 4.2, we'll look at 4.3. So who needs this packet still? Does anyone need the 4.2, 4.3 homework? Does everyone in here have this packet, hopefully? Yep. Okay, make sure you have this packet. If you don't, let me know, and I'll get you a copy of it. Now, last time we did 4.2. Today, we're going to be looking at 4.3. And 4.3 is logarithms. So we'll start by talking about what logarithms are and how to convert logarithms to exponentials. Now, a logarithm is a way to show a large change as a small change. Lots of examples of logarithms, and we're going to cover a lot of examples, but one that we're probably familiar with is an earthquake. We talk about an earthquake, a magnitude 5 on the Richter scale is a really, really large earthquake. It does a lot of damage. But when we look at a 3, you may not even hardly feel it. So to go from a 3 to a 5, that's a big change. And a big change is represented by a small change. That's what logarithms do. A lot of times we use a factor of 10, power of 10. Or we use a natural log, which we'll talk about the natural log more next class group. But today, we're going to be focusing on using the logarithms, and we'll use log base 10 for a lot of these, and how to convert them to an exponential. So we have a formula, and I'll give you the page number in case you need to look it up. But it's how we can convert a logarithm to an exponential. And a lot of times, it's easier to solve something as an exponential than it is a logarithm, or vice versa. And this is going to be 4.2. We're going to be looking today at, or is it 4.2 or 4.3? It's actually, let's make sure I'm the right section. Last time, remember, we covered 4.2, so sorry about that. This is 4.3. Logarithms is 4.3. 4.2 is exponential, so this is 4.3. We're going to be talking about logarithms. And the page in your textbook with the formula is on page 463. And it's just this. Y equals log base A of x converts into x equals a to the y power. And it can go either way. Double arrows mean it can go either way. You can take a logarithm, turn it into an exponential, or you can take an exponential and turn it into a logarithm. In many cases, you may have to convert it because it might not be solvable as a logarithm, but it might be easily solvable as an exponential, or vice versa. So we're going to be learning how to convert these. So the first thing we're going to learn how to do is we're just going to learn how to convert these. So I'm just going to pick some from our textbook. So let's look on page 473. And all we're doing here is converting. And so we're going to convert the exponential to the logarithm, and then we'll do the logarithm to the exponential. So question, we'll do question 12 here. We have this. We have 2 to the 5th power equals 32. Now, this is an exponential, and we want to see how to convert it. we just label the pieces. So look at your formula. There's your x. This is your a, and the power is your y. So it might be in a different order, but the 2, that is going to be your a. The 5, that is going to be your y. And the 32, that is your x. So if I convert this to a logarithm, what would it look like? Okay. Logarithm is y, which y is that 5. So 5 equals log, and this is said log base, in this case a. Ours is going to be a different base. Ours is log base 2 of x, which is now our 32. So I converted it from an exponential to a logarithm. See how I labeled the pieces? Okay, let's do another one. Let's convert question 13. 2/3 to the negative third power equals 27 over 8. How would we convert it? Well, this 2/3 here, look at your formula. This 2/3, that's going to be your base a. So this is your a here. This power, that is your y. And 27 over 8, well, that is your x. So now looking at our formula, when we convert it, y equals log base a of x. What does ours convert into? Y, which is that power. So that's a negative 3. It equals log base. What's our base? Base in this case is that 2/3. And then what's our x? Well, our x is 27 over 8. So I just converted this exponential to a logarithm. Now let's go the opposite way. Now I'm going to give you a logarithm, and you're going to convert this into an exponential. So log base 6 of 36 equals 2. Let's take a moment, go back and look at our formula. Y equals log base a of x. So let's label our pieces. Y is by itself, so in this case, the y is the 2. Okay. The number below the logarithm, that is your base. So this is a base a, is 6 here. So base 6, that's my logarithm. Okay, that's your a. And this 36, that is your x. And what does it convert into? Well, it converts into x equals a to the y power. And so this would convert into then 36 equals 6 squared. And we know that's true, and we know that we did it correctly because 6 squared is what? 36. All we are doing on these is just simply practicing conversions. Not difficult at all. We're going to use these conversions in a moment to solve equations, but right now we're just converting. How about question 17? Let's try to convert 17. Seventeen is log base square root of 3 of 81 equals 8. Well, we know that square root of 3. That is your a. So we know that's your a there. We know the number inside. That is your x. And we know the number on the end by itself. That is the y. So what does that convert into? Write up your formula if you need to. X equals a to the y power. So what would that convert into? Well, that would convert into 81 equals square root of 3 raised to the 8th power. Is everyone okay with how I converted those? So we just write up our formula and convert. That's all you have to remember is your formula. Now, we're going to be using this to help us solve some of these equations. We may have to take it from a logarithm to an exponential, or from an exponential to a logarithm so we can solve it. So convert it, and then use different algebraic techniques to solve. So let's look at question 20. Question 20 is x equals log base 3 of 1 over 81. Okay, here's our formula. Here's our conversion formula. So let's get our pieces. That x, well, that is your y. This 3, that is your a. And the 1 over 81, that is your x. So let's follow our conversion formula. And what does that convert into? Well, that now converts into 1 over 81 equals our base 3. So that's our base 3 here. And what is our y? Our y is the x. We covered these last time, right? Now, how do we find that value of x? Well, to get that x, we need to make sure that our bases are the same. That will force your exponents to be the same. So we need to turn that 81 somehow into a 3. It's a fraction, so let's use our negative exponent rule. So we can write this as 81 to the negative first power. And that equals 3 to the x power. Right? We're getting closer. What do we know about 81? Well, we need a base of 3. So 81 equals 3 to what power? Let's try it. We can just try it until we find it, but it's going to equal 3 to some power. 3 squared is what? No, it doesn't work. 3 cubed, 27. But what about 3 to the 4th power? That's 81, isn't it? So what does that now become? 3 to the 4th is 81. This is negative, so we keep it negative. So that tells us now that 3 to the negative 4th power equals 3 to the x power. Bases are the same, so what does that tell me? Those are the same. Bases are the same. That forces the exponents to be the same. So now we know that x must equal now what? X must equal negative 4. So we converted it to an exponential. And we used our rules of exponents to solve it. Let's do another one. 22. 22, the x is now the base. So we're going to have to solve it a little bit differently. Let's look at question 22. It's a logarithm, so we're going to convert that logarithm into an exponential. And again, if we need our, pull this up here, if we need our formula, put it up so we can see it. Here's our conversion formula again. I think it's helpful to have it. So, what do we know? What are our pieces? Well, this x, that lines up with the a. This, the whole part, is your x. And this 3, well, that is your y. Rewrite it and see what we have. So when I rewrite it, we have x. So what was x? X was 27 over 64 equals a, which is the x power. And what was my y? Or sorry, x base. So what was my y? Y is 3. Okay, now, how would I solve this? Well, the last one, we had to get the bases to be the same, right? Force the exponents to be the same. The converse is also true. If I can force the exponents to be the same, then the bases must be the same. So let's see what we can do with this 27 over 64. Figure out what's going to go here. What number cubed makes it 27? Can anyone tell me? Okay, what number can I cube to make it a 27? 3, right? 3 cubed is what? 27. What number can I cube to make it a 64? Let's start with numbers. 2 cubed is not, that's 8, not 64. 3 cubed you said was 27, right? What about 4 cubed? Let's check that one out. 4 cubed. Well, 4 cubed is what? 64. So that means we need a 4 down below. So now, what can I do? Well, I can now rewrite this 27 over 64. I can rewrite that as 3/4. The third power equals x to the third power. So I'm okay with that. Now, what do we know? These exponents are the same. So that means the bases must also be the same. So that tells me that x is what? X is 3/4. And that's it. Just use your conversion factor there. Let's do another one. Let's see what we can do with question 24. 24's got a 5th root in there. We have a square root also, so let's see what we can do with question 24. They're not hard. They're actually pretty easy to do. Hold this so we can keep our formula here so we can see it. Okay, so here's our formula. And we're going to look now at question 24. X equals log base 7 of the 5th root of 7. It looks a little bit intimidating with the 5th root, but that's not going to be a problem. All we need to do is line up our pieces. So this x, well, that's your y. This little 7 down below, that's your base, so that's your a. This entire part is your x. Convert it. Let's see what we have. When I convert it, we've got the 5th root of 7. That's our x. There's our formula. So there's our x. Is going to equal base 7 now. So that's your a. and that's going to be to the x power. So I want to make these the same. We want a common base of what? We want a common base of 7. Now, this one's a fifth root. I want to make it a base 7. So how would I get rid of that? Or how can I rewrite it? Okay, if I rewrite this, sometimes we may need this one. This is just something that we use once in a while with our roots. We don't use it that often. But the nth root of a is a to the 1 over n power. We don't use it that often, but you can write roots like this. The most common one is a square root. The square root would be a half power. Okay? This one is a fifth power. So I could rewrite that as 7 to the 1/5 power equals 7 to the x power. Nothing else to do, because now we can look at it and we can tell that x is going to be what? Easy enough, 1/5. Not a lot of algebra, it's just using little tricks. Let's try another one. How about question 32? See if we can figure out question 32. And I'll move it so we can see what we've got here. Okay, log base 2 of x equals 3. Again, convert it. So here's our formula. There's your a. X is the x, and the 3 is the y. And relabel. So x is x, no problem there. A is 2, y is 3. And that's easy. There's nothing really to do, because we know that 2 cubed is what? Okay, 2 squared is 4. 2 cubed would be 8. So what's our answer? Simply x equals 8. Right? So all we need to do is get that variable by itself. Sometimes you may have to get a common base. Sometimes you may have to get a common exponent. Or like this one, you just work out your power. Let's look at question 37. This one's going to require a little bit more conversions here. If you need to leave early, make sure that you sign the sign-in sheet. It should be around here somewhere. Just had it a second ago. I think. Yeah, if you need to leave early, make sure you sign the sign-in sheet. I know I had it around here somewhere just a second ago. Let's see. Leave it somewhere else. Oh, here it is. Yep, so if you need to leave early for a game or anything, I know some of you might need to, just make sure that you sign that sign-in sheet before you leave. So if you need to leave early, I'll put it over here. Again, if you need to leave early, like I know some of you need to leave it. I know Pascal need to leave at noon, so make sure you sign that sign-in sheet before you leave. All right, so let's go back now to these logarithm questions, and we're going to look at, I believe I said question 37. So we're going to look now at question 37, and we're going to be converting and working with it. So question 37 is log base of 1/2 of x plus 3 equals -4. What do we have? We have a logarithm. So what do we need to do? Convert this back into an exponential. Looking at our formula, that's our a. This whole part right here, this entire part, is the x, and this -4 is the y. So it's simple enough once you see the conversion. Not much to do with these. Convert it. So what does that convert into? Well, that converts into x plus 3. That's your x there. Comes down here. Equals a, which is 1/2 to the -4th power. Now we just work it out. You can use a calculator if you want, or you can work it out with your rules. I'll do both. I'll show you how to use a calculator to work this out, as well as how to use the rules. On this one, it's pretty easy to use a calculator. Well, we know that 1/2 is 0.5, right? We want to raise this to what power? -4th. How do we raise things to a power? We use the caret key. And we need a negative. We don't use this negative. We use the negative at the very bottom, the plus or minus one. Okay, so push that in. And then what are we taking it to? The -4th power. What does that come out to give you? 16. You can either use a calculator, or you can work it out like this. So 1/2 to the -4th power is the same thing as flipping it over, 2 to the 4th power, which is the same thing as your 16. Either way, how do we finish it? We solve it for x. So we just simply move that 3 over, and now we have it with x equaling 13. Easy enough there. Okay, let's look at one more, and then we're going to look at some graphs. So let's do another one, and then we'll look at some graphs here. Question 40. So we'll look at question 40. And then we'll see how to graph these logarithms. Log of x minus 4 of 19 equals 1. So first thing we do is we use our conversion formula. Convert it to something that we can use here. That is your a. That 19 is the x, and that 1 is the y. So let's see if we can rewrite this and work it out. Well, we know that x is the 19, so 19 equals a, which is x minus 4, and y is a 1. I just converted it. Now don't try to make this one more complicated than it needs to be. A power of 1, what does that mean? It's just itself, right? So what does that come out to be? Well, we don't even need that 1 there. So that's going to be x minus 4. The other side is your 19. So we could just add that 4 over. And now we have x equaling what? 23. Easy enough. They're not difficult once you do the conversions. Now that we've seen the conversions, we're going to graph them. And exponentials and logarithms are inverses of each other. So exponentials and logarithms are going to be the inverses. So when we go to graph these, we're going to be looking at kind of like an exponential graph, but it's going to be the opposite way. So let me go to the back cover of our textbook. And the graph of the logarithm, what it looks like, is based upon which base you have. So if we go down here, again, here's our logarithm graphs. Remember last time we did the exponentials. The inverse of an exponential is the logarithm. Now, there's a logarithm for when your base is bigger than 1. And there's a logarithm for when your base is a fraction between 0 and 1. They all have the same common points. A comma 1, 1 comma 0, and 1 over a minus 1. It's the opposite of the exponential, because these were the opposite. Remember, the 1 over a went in the opposite place. And instead of 1, 0, well, this one's 0, 1. So when we go to graph these, we need to make sure that we find the points. So let's just graph a couple of these. Let's graph y equals log base 4 of x. Well, 4 is what? 4 is definitely bigger than 1. You look at your base. 4 is bigger than 1. So this quick sketch of the graph looks like this. Now we always need to find the following points. We find the points, which we have them right here. We need a comma 1. We need 1 over a comma minus 1. And you always use the point, make sure I don't get mixed up here, 1, 0. It's the opposite of the exponential. And when we connect them together, it's going to make a graph like that. So what is our a, by the way? That's your 4. 4 is your a. So what do my points look like? Well, a comma 1. That would be 4 comma 1. Then we have 1 over a, so that's 1 over 4. That's a fourth there. And then we have a minus 1. And then we have 1, 0 there. We've got all of our points. Now, we know the graph should look like what? Similar to this. So let's graph this one real quick here. We've got 4, 1, which is right there. That's our first point. We have 1, 0, so that's at 1, 0, so that's 1, 0 there. And then we've got minus 1, so that's down 1, and over about a quarter. That's 1/4 comma minus 1. Now, just like with the exponentials had a nice horizontal line, right? Logarithms have a nice vertical asymptote, that vertical dotted line there. And when I connect them together, we can get our graph. You just plot those 3 points, and you connect them together, and there's your logarithm graph. That's the graph of y equals log base 4 of x. So pretty simple. You just find these 3 points. This one's always the same. These change based upon the a. So let's graph another one. Let's do a fractional power. How about y equals log base 1/3 of x? So let's try to graph this one. Now, again, we need these points. So we need a comma 1. We need 1 over a comma minus 1. And we're always going to use that 1, 0. Now, this one should look like this. Okay, it should go the opposite because that base is a fractional base, and it should look like this. So it should look similar to that. Why? Because this is your a, and that is less than 1. It can't ever be negative, but it can be a fraction. So if it's a fraction, that again is your a, and it's going to make the graph look similar to that. So let's get our pieces. A is 1/3, so that's 1/3 comma 1. We need 1 over a third. Well, 1 over a third would make that then a 3 and negative 1. And then we're going to use that 0.10. Now we have all the points that we need. We can now go ahead and convert them. And plot them and graph our line. Okay, so let's start with our vertical line here. And that's going to be at, if you want to label it, x equals 0. When we label them, 1/3 comma 1, 1/3 is here, and it's up at about 1. So it's right about there. Make that look right here. We've got 1/3 and 1 there. So there's that point. And then we've got 3, negative 1. So that's going over positive 3, down 1. And that's going to be right about there. And then we also have 1, 0. So it's over 1 at 0. And look at what happens when we connect them together. Remember, it cannot cross that dotted line. When we connect them together, it looks like that. Is everyone right with that? Now, the same translations that we apply to all the other graphs apply to this as well. So we can move this graph up and down, left and right. And let's do some of those. The same basic concepts. I want to graph this equation here. So, where's that positive 3 at? That positive 3 is inside the parentheses. And remember from last chapter, if it's inside the parentheses from our last exam, and it is positive, what does that do? That is going to shift it backwards, won't it? So that's going to make it start back 3 units. Now, normally, we have a vertical line at 0. So this is going to make our vertical line move back 3 units. So the other ones were at 0, right? This one's going to have a vertical line at -3. So is everyone okay with that? So that just moved it back 3 units. That's all it did. Now, what about our points? Our original points are a comma 1. We have 1 over a, comma minus 1. And then we have 1 comma 0. But what are we going to have to do? We're going to have to move this what? move this back 3 units. So if I move these back 3 units, what does that do? Well, that makes this one a minus 3, comma 1. That makes this one now, moving it back 3, 1 over a minus 3, comma minus 1. And then this one now is at 1 minus that 3, comma 0. Okay, we didn't move it up or down. All we did was we moved it back 3. Move it back to the left 3 units. That comes off of the x, because that's what we're doing. We're sliding it back 3 units. So what are our new points? That again is your A. So let's fill in our new points and see what we have. So what are they going to be? Well, our first one, base is 5. So that's 5 minus 3, comma 1, which is then 5 minus 3, that's a 2, comma 1. So let's plot that point. We'll just plot them as we get them. So 5 minus 3 is 2. So it's 2, comma 1. So that's over 2 and up 1. There's that point. What about the next one? Well, the next one is 1 over a minus 3. So that's 1 over 5 minus 3, minus 1. And we can just write that as a fraction or decimal, either way you want to do it. 1/5 minus 3, well, that would be a minus 2 and 4/5. I just use the mixed fractions there, comma minus 1. So that's going to be at about minus 3. Pretty close, right about there. And we're going to go down 1. So there's that. Is minus 2 and 4/5, comma minus 1 there. And the other point, well, it's 1 minus that 3. And 1 minus 3, that makes it a 2, comma 0. And 2, comma 0 is right here. Okay, so so if that one, sorry, minus 2. My mistake there. Yep, sorry, sign error. That should be a minus 2 there. Okay, so minus 2, 0 is right here. We've got our 3 points now. And we just simply connect them together. And that's your graph. What did that negative 3 do? Or sorry, that positive 3 that was inside the operation, inside those parentheses. So what did that do? That moved it back 3 units. So all the x parts had to be adjusted by what? 3 units back. So that's why all of these were minus 3s. Let's do another one. So let's try to graph this one. So that minus 4 is inside, opposite of what you think it would do. So this slides it forward 4 units, doesn't it? So that is going to be our vertical line here, vertical asymptote. We use those terms in chapter 3, section 5. That asymptote, that's what that's going to be at 4. 1, 2, 3, 4. Okay, so there is our vertical line. And that's going to be at x equals 4. So what did that do to our points? Well, the original points that we need are always the same. A comma 1, 1 over a, comma, negative 1, and 1, 0, what are we going to have to do? We're going to have to move this to the right 4. So that means we've got to add 4 to all the x values. Y values stay the same. So all I did there was add 4 to all the x values. Y's stay the same because we're not adjusting that at all. Fill them in. What is our a now? It's a half. Just fill it in. And what's it going to be? Well, it's going to be a, which is a half, plus 4. 1, and I'm just going to make this easy. You can use a decimal if you want, but it's easy enough to work with. A half plus a 4, that's 4 1/2, comma 1. So there's that one. So 4 1/2, comma 1. And then we've got 1 over a. Remember, a's a half here. So what would this one be? So what would 1 over a, well, 1 over a would be a 2, right? 2 plus 4, comma, negative 1. What does that give you? 2 plus 4, that gives you a 6. And minus 1, we have that point. We've got our last one. We're moving it over 4 units, and we're adding 4 here. So that's going to be at 1 plus 4, comma, 0, which 1 plus 4 is 5, comma, 0. Those are our points. We're going to plot them. 4 1/2, comma 1. Well, 4 1/2 would be right about there, up 1. The next point is 6, negative 1. So there's 5, 6, down 1, right about there. And the last one is at 5, 0. So 5, 0 is going to be right about there. Connect them together. The curve, just like that. Let's do one more. This time, I'm going to add a number on the end. Now, what do we know about numbers on the end? Move it up or move it down, right? So that's going to shift it up and down. So let's try to graph this. Let's try to graph y equals log base 3 of x, and we'll put a minus 4 over here on the end. Okay, that minus 4 is on the end, way over here. So that minus 4, that's going to move all my points down 4. So let's write up our original points. Our original points are a, comma 1. Thank you very much. I'll get that graded. Maybe not this afternoon, but I'll definitely get it done before tomorrow. So that is going to move our graph up. We're not moving it left to right. We're not moving it up. We're moving it up, or sorry, in this case, down 4. So that's going to shift our points down 4. Now, what is the up and down part? It's not the x values, it's the what? Y values. So how is it going to switch those around? It's going to change them a bit, because if my original was a, comma 1, okay, we're going to move it down 4. So that means we've got a, comma 1 minus 4. So we have to move it down 4 units. Right? All that does is move it down. And then if our next one is 1 over a comma negative 1, well, our new one would still be 1 over a, and we're going to move it down, what? 4. So that's minus 1 minus 4. And our last point is 1 comma 0 for our original. We're going to move it down, again, 4 units. So that's 0 minus 4. So let's plug in our values. Our a is what in this case? A is 3. So plugging in our values, what do we get? We get 3. That's your a. 1 minus 4. Well, 1 minus 4 is a minus 3. So that's a point we'll be using. 1 over a, so that is 1/3. Minus 1 minus 4 makes it a minus 5. And what about the last one? Well, it's just 1, and 0 minus 4, that's a minus 4. Okay, let's plot our points and see what happens to our graph. Well, first off, are we moving the graph left or right any? No. So that means the vertical is going to stay the same. So the vertical should still be here at x equals 0. We didn't move that left or right any. It should still be there. Well, let's plot our points and let's see what happened. Well, we've got 3, negative 3. So that's forward 3, down 3. And then we've got 1/3, negative 5. So that's positive 1/3, and down 3, 4, 5. So that's going to be right about there. 1/3, comma, minus 5. And then we have 1, negative 4. So that's going to be right about there. And when we connect them together, my graph might be off a little bit, but when we connect them together, it looks like that, right? What did we do? We moved that down 4 units. So we just took the regular graph that we would have, and we shifted it down. That's all we did. This should be about negative 4 there. I'm going to work through now one of the questions from your homework, because I gave you 2 of these. Well, actually, I'll work out 2 of these, so 1 of each one. I'll work out question 7, and I'm going to work out question 10. So we'll start with question 7. We should have just enough time to get through these. So we're going to look at our homework questions here, and we're going to look at our homework, and this is 7, or sorry, not 7, let's think of intermediate algebra. This is 4-3, and we are going to be looking at question 7. And it says, use the properties of logarithms to evaluate this expression. So we have log base 10 of 0. Make sure we have the right number of zeros, 1, 2, 3, 1 to the 9th power. Okay, now, what do we need to do? We need to use our properties of our logarithms to evaluate this down. We want to find the answer, so we want to find x. So we're going to make this equal to Rx. We want to find out what x is going to be. We can now convert this, because what is our conversion formula? On the paper here, I can write it up again, but we have it somewhere as well. Oh, here it is. Here's our conversion formula that we're going to be applying. Okay. So let's convert it. Let's see if we can get this to work. Well, our A is 10. This entire part right here is your x. And we can make this y if you wanted to. It wouldn't matter. I just called it x, but this is going to be your y. So when we convert this, let's see what it is going to convert into. And I'll show you another trick after we convert it as well. There's another trick we could use, which I'll show you, but we're going to do this one with conversions. See if we can figure it out with conversions. And we now know that 0.00001 to the 9th power, because that's your x, is going to equal a, which is 10, to the unknown power, which is, in that case, your x. So there's our conversion. Okay, so let's see if we can't convert this. Well, how would we begin? I can easily convert this into scientific notation. So in terms of scientific notation, I can convert this by moving this over 1, 2, 3, 4, 5 places. Okay? So that could convert into now 1 times 10 to the 1, 2, 3, 4, 5 power to the 9th. And that gives you now what? That gives you multiplying these together, because you've got to multiply. 9 times 5, that's a... well, we have 1, 2, 3, 4. Remember, 5, because we'll put the decimal point right there. Make sure I've got... Did I not have enough? Did I have too many zeros? Let's make sure. It's easy to not put enough for too many. Yep, you're right. Should be 4. My mistake there. You're right. Should be 4. Sorry about that. I got too many zeros there. Okay. So when you multiply those together, we get... Well, actually, let me convert it. Make it a little bit easier. We'll just do it as a power of 10. Let's make this 10. This way it'll look out nicer. So let's convert this. This way we can get it all to the power of 10. So we've got 0.00, make sure you have the correct number of zeros, 1 to the 9th power. That is going to equal 10 to the x power. Make sure we convert it correctly, because I want to convert it into a 10. So if I convert it, this is 1, 2, 3, and we'll add one more. Let's make sure it looks right here. So 1, 2, 3, 4, and we'll add one more to make it a 10. So we want it to be 10, just like this one. So that would convert into 10. And how many places am I going to have to move over? I've got to move over 1, 2, 3, 4, 5. So we'll be minus, since we're moving it over to the 9th power. And there is an easier way of doing this, and I'll show you what this will be here in just a moment. What do we know about this? Using our rules, we can multiply. So that's going to be 10 to the negative 45th power. And what do we now know? Are our bases the same? Yes. So if our bases are the same, then our exponents must also be what? The same, right? And so what does your x have to now be? X has to now be negative 45. So I had to convert this into scientific notation. Okay, and then remember what happens here. I had to multiply. I could have done it a little bit easier. If these bases are the same, then your x becomes your exponent. So you could have just done this. You'll get the same result. It's the exact same thing, just looks a little bit different. could have went and I could have converted this 1, 2, 3, 4, again, 5 places to make it a 10. And that would be log base 10, 10 to the minus 45th power. Okay, and if the number inside is the same, if these are the same, then it just becomes your power. So it could be the same as just simply writing it as negative 45. You could have done it that way. Okay? Because whenever your base and the number inside are the same, your power can just come down. But what I needed to do is I needed to make it 10. Why did I need to make it a 10? Either way you look at it, it's got to be a 10, right? If I convert it, why does it have to be a 10 here? Because this side's a 10. And how did I do that? I went 1, 2, 3, 4, 5 places over. That made that a 10. And that's times 10 to the negative 5th here. And then I multiplied those, and that gave me that 45. So let's look at the very last one here. That was question 7. Just so you can do these all workout question. I did 7, let's do 10. This will be our last question. And they give you this. They give you, this is from your homework. They give you this. F of x equals log base A of x. Now we know that f of 5 equals 2. Yep, and I'll pass out that sign-in sheet in just a second here, or you come up and sign it before you leave. All I need to do is plug the numbers in, find the missing part, and then we'll find f of 125. So we want to find, at the end, f of 125. So let's think about what we know. What does this 5 represent? That goes with that x. So this is your x, right? So we know that when you plug in 5, that goes in for the x. So what we have is f of 5, that's 2. So that means this part right here is 2. That is going to be the log base A, and what number are we plugging in? We're plugging in a 5, right? Because that's your x, so that goes in there. This 2 is what it equals over here. All right, thank you very much. Yep, I'll get you those here in just a second. I just need to finish this real quick. So just give me another minute or two, and I'll get it for you real quick. So we can now find the A because we can convert. Right? We can convert this pretty easily. And we can find our A. We know, if we go back to our formula again, y equals log base A of x. So my 2, that's your y. Your A is the A. And the x here is the 5. So when we convert it, we now get, let's rewrite this real quick here. We can now convert this, x is 5 equals A to the y, which is second power. And how can I rewrite this? Well, I want to make sure, well, we don't need to rewrite, we need to solve it. So how can I solve this? We've done a lot of these. 5 equals that a squared. How do I now get rid of a square? We've done a lot of these. The operation we can do is a what? Square root. Now we don't have to worry about plus or minus. Why do we not have to worry about plus or minus? We don't have to worry about plus or minus because it can't be negative. So that gives you a as a square root of 5. So now our formula, when we find it, is f of x equals log square root of 5 equals x. And we want to find, sorry about running out of time here, we want to find f of 125. So this is our x, and we'll just simply plug it in. And we can convert it and solve it. Okay, so let's convert this real quick here. Sheet of paper. So now we're converted, and we'll just call this our y. Using our formula again, this is what we're converting. Okay, so this is what we want to find. F of 125, we have to convert it. So this would be your y. This would be your a again, and this would be your x. So when I convert it, we should finish just right on time here. That gives you, when you convert it, 125 equals the square root of 5 raised to the y power, right? How do we now finish that? We can rewrite it. Okay, we can rewrite 125 as 5 cubed. We're getting closer. We're going to try to get these to be the same. What else do we know? Well, we know that the square root of 5 is the same thing as 5 to the half power. Or you can rewrite it as 5 squared equals 5. Same thing. We need to convert this. Now, we want to convert this to the square root, so we have to square that. So that'll be the square root of 5 squared to the third power. And I know these are a little bit confusing. And sorry about rushing through this, but I want to make sure we finish it. Almost done. 2 times 3 is 6. And now our bases are the same. So what do we know about our exponents? They have to be the same. So y must equal now what? 6. I'm going to leave 9 for you to do. Okay, I did 10. I think that was the harder one. I'll leave 9 for you to do. And you can also do question 8. You got to convert that to a exponential. Okay, so what's our homework, just so we know? Well, your homework is going to be 4.3. You should be able to do them all. I will see everyone then on Tuesday of next week.